question says the diagram below shows the velocity time graph for the motion of the particle P which moves on a straight line BAC. It starts at A and travels to B in 5 seconds. So this should be A and this should be B. It then reverses direction. We can also see that from the velocity time graph. Velocity was negative, now it is positive. From B to C, taking 10 seconds. 5 plus 10 is 15. This should be C. For the first 3 seconds of P's motion, its acceleration is constant. We can see the straight line in the graph as well. For the remaining 12 seconds, velocity of P is v meters per second at time 3 seconds after leaving A and is given by this equation, which is valid for 3 to 15. First part says find the velocity of v when t is equal to 3 and the magnitude of acceleration of P for the first 3 seconds. So first part says find the velocity when t is 3. So I have this equation and it is valid at time 3. So velocity is equals to negative 0.2 t square plus 4t minus 15. We plug in the time, negative 0.2 3 square plus 4 into 3 minus 15, and use of calculator, negative 0.2 times 3 square plus 4 3 times is 12 plus 15 minus 15 minus 15, and we get negative 4.8. Negative 4.8. Let me correct this. That was negative 15. That's an overlap. Negative 4.8 meters per second. Second part of the same question says magnitude of acceleration. So for magnitude of acceleration, we can find the gradient. Acceleration is gradient of this graph. Final velocity is minus 4.8, initial velocity is 0, 3 minus 0, and 4.8 divided by 3 gives me 1.6, negative 1.6 meters per second square. Second part says find the maximum velocity of P while it is moving from B to C. So while moving from B to C, this is the maximum velocity, and the equation part will give it. For maximum velocity, we need to do the derivative. Velocity is negative 0.2 t square plus 4t minus 15. So dv by dt is equals to negative 0.4 t plus 4. We substitute 0 to get the maximum point, negative 0.4 t plus 4, and 0.4 t is equals to 4, t is equals to 4 divided by 0.4 is 10. So at time 10 seconds, we have the maximum velocity. Using the same equation again, velocity is equals to negative 0.2 using time t 10 plus 4 into 10 minus 15, and negative 0.2 into 10 square plus 4 into 10 minus 15 is 5 meters per second. So this speed right here is 5. This was minus 4.8. Third part, find the average speed of P. For average speed, I need to know the total distance while moving from A to B and for the whole journey. So question third, A part. So when moving from A to B, there are two sections. One is the graph. I need this area, and the other is the area under the curve. So we'll use the equation of velocity to convert it into distance or displacement equation. So first section is area under the graph, 1 by 2 into base into height. So 0.5 into 3 into 4.8 gives us 7.2. Now for this section shaded in green, we have the equation of velocity is equals to negative 0.2 t square plus 4t minus 15, and the mnemonic was SVA displacement time, velocity time, acceleration time. From velocity time we need to integrate to get the displacement. So that is integral dt, and we do have the limits from 3 to 5 already. 3 to 5. So I'm integrating 3 to 5, negative 0.2 t square plus 4t minus 15 dt. This becomes negative 0.2 t cube by 3 plus 4t square by 2 minus 15t from 3 to 15. So upper limit negative 0.2, that is 5 cube by 3 plus 2 into 5, this is 2 1 times and 2 2 times, 5 square minus 15 into 5. Upper limit minus the lower limit, negative 0.2 3 cube by 3 plus 2 3 squared minus 15 into 3, and this. Using calculator, negative 0.2 into 5 cube over 3 plus 2 into 5 square minus 15 into 5 is giving me negative 100 by 3, minus, replacing all the 5's with 3, and it gives me negative 144 by 5. 100 by 3 plus 144 by 5, and that gives us negative 68 by 15, which is negative 4.53 recurring meters. Now we are going to change this negative sign into positive. This is just because it is below the x-axis, that is negative, and distance cannot be negative. So therefore it is 4.53 meters. Now for the first part, average speed is total distance over total time. I have these two distances. First was 7.2 meters and the next is 4.53. So 7.2 plus 4.53 total distance over total time. Time is from 0 to 5. So for this section A to B, average velocity is 7.2 plus 4.53 by 5, and it comes out to be 2.346, approximately equal to 2.35 meters per second. And for the remaining part, B part says for the whole journey. So for the whole journey we need the whole distance. We already have the equation for displacement. Now we use the limits from 5 to 15 in the same integrated equation for this displacement, and that was, let me zoom out. Okay, so displacement is equals to, now the limits are from 5 to 15, and this is negative 0.2 t square plus 4t minus 15 dt, and I'm copying it directly, we've already integrated it. So that would be negative 0.2 t cube by 3 plus 2t square minus 15t, and from 5 to 15. Now we plug in 15 first, negative 0.2 t, this is 15 cube by 3 plus 2 into 15 square minus 15 into 15 minus the lower limit. For 5 we have already solved it. Upper limit was 5 and answer was negative 100 by 3. So negative 100 by 3, we just copy that down and using 15. This is 15 cube into 15 square, and last one 15. punching it again. Negative 0.2 into 15 cubed by 3 plus 2 into 15 square minus 15 into 15. I'm getting 0 plus 100 by 3 is approximately equal to 33.3 recurring. So now the total distance becomes 7.2 plus 4.53 plus 33.3 divided by the total time. So average velocity for the whole journey is 7.2 plus 4.53 plus 33.3 by 15 is 3.002, approximately equal to 3 meters per second. And that was the last part.